Hello people, this is just a quick video explaining how we multiply decimals and integers. Decimals are numbers with value past the decimal point and integers are whole numbers, so 7 is an integer but 7.2 is a decimal. Okay, a lot of people get confused with these because we kind of take a place value rule and just chuck it in the bin. Normally, when you're doing column subtraction or addition, you'd have to line up tens above tens, units above units, but we kind of ignore that for multiplication. What we just do is put the two values on top of each other. So 47 times by 3.2, we don't put the 7 units on top of 3 units. We actually, for this trick, which is what it is, we put the number up there. Then we use the normal short division algorithm. So to calculate this, I just change my color, I'm going to start with the 2-digit in the bottom right, and I'm going to multiply by up here. So 2 times 7 is 14, which is 4 units and 1/10. However, this is actually not 4 units. It's actually a decimal number, so I need to keep my decimal point. 2 times 4 will be 8, add the 1, 9. So I've actually got 9.4 here. I've used my 2/10 there, so I put a placeholder in. Decimal point. 3 times 7 will be 21, so I put a 1 digit here. Generate an extra value of a 2. 3 times 4 will be 12, add the 2 will be 14. Except it's not actually 14, is it? It's actually 140. Again, this method is a trick. And at the very end, I'd add together underneath, I'd have 4/10, 10 units, which generates value over here. 4 and 1 is 5, 5 tens and 100. Give me the answer 150.4. Slightly different example. Nothing to be too worried about though. I've got 7 and I've got 6.24. I'm actually going to put the longer number on top. There's a reason why I'm going to do that. I'm going to put the 7 underneath because then I only need to know my 7 times table to actually solve these correctly. 7 times 4 is 28. So I've got an 8-digit here. 2 tens represented there. 7 times 2 is 14. Add 2 more onto that value. So I've actually got 16/10 here, which generates the extra unit. Decimal point in the correct position. 7 times 6 is 42. Add the 1 there will be 43. And I have my answer of 43.68. So with this one here, I put the longer number. It is not larger. It's just longer on the top because then I've only got 1 digit at the bottom and I only need to use the 7 times tables. Slightly different example here because I've increased the size of the integer. I've now got 35. Split the digits there for no reason whatsoever. And I got 2.73. I'm going to use the same little piece of advice I used in the last one. I put the longer number on top. It is not the larger number. It's a lot smaller than 35. It's just longer. And I use normal short multiplication algorithm. So 5 times 3, that'll be 15. So I've got 5 hundredths and a tenth. 5 times 7 is 35. Add the 1 there. I've got 36 tenths, which is actually 6 tenths and 3 units. 5 times 2 is 10. Add the 3 will be 13. It's 13 ones, which is 3 ones and a lot of 10. Very important. I remember my decimal point here. Now, the bottom number here's got 2 digits. I've used all my 5s, so I'm going to put a place holder in. And I'm moving on to this 3-digit here. So 3 times 3 will be 9, which is actually 9/10 for this problem. 3 times 7 is 21. 1 unit, 2 tens. 3 times 2 is 6. Add a 2, 8. So I've actually got 8 tens there. I'll then add those two numbers together underneath, giving me 5 hundredths, 15 tenths, which generates an extra unit. 3, 1, and 1. I've got 5 units, and I've got 9 tens. So an answer of 95.55. I'm just going to erase a little bit of generated value here. So it's 95.55. So some little help was there to avoid you making any daft mistakes, I hope. And by all means, come back and watch the video if it helps you in the future.